Hello guys, welcome to my YouTube channel. My name is Trisha Reddy G and my USN is 1BE22IS055 and I am studying in Sri Venkateshwara College of Engineering. So today we are going to discuss something about additional list operations, sparse matrices and double linked list. Now let's move on to our topic. A single linked list is also called as singly linked list. Now, what is a singly linked list? A single linked list is a linear collection of nodes where each node has some data and a pointer to the next node in the list. So basically, in a single linked list, there are two types of memory. So in one part of the memory, you're storing the value. In another part of the memory, you're storing the address of the next value, wherever the next value is being stored. So now in a singly linked list, we can traverse the list in only one direction. You can only search, sort or display. Whatever you can do is all in one direction. You cannot come back, you cannot traverse back. Okay, so now the main advantage of using the linked list over the three types is that it requires less memory. So in compared to double linked list and everything, in single linked list, since we are traversing in only one direction, it requires very less memory. Now, what are the operations we can perform in the linked list? That is traverse, insert and delete. So there are various linked list operations that allow us to perform different actions on the linked list. For example, the insertion operation adds a new element to the linked list. So here's a list of basic linked list operation that we will cover in this article. First, traversal. That means you're going to access each element in the linked list. As I said, you can traverse only in one direction. Insertion. Insertion states that it adds a new element in the linked list. Insertion, you can add whether in the beginning or in the end or in the middle. Deletion also is the same. You can add, you can delete in the beginning, delete in the end or delete in the middle. So deletion removes the existing elements. Search, you can find a node in the linked list. Sort, you can sort the linked list. It is easier in a single linked list because it is traversing in a single direction. So sorting becomes very easier. Now, before moving on to the topic, let's learn some things you have to remember about the linked list. So there is something called a variable head that points to the first node of the linked list. And then there is a variable called next that points to the last node of the linked list. So basically your last node will be your null. Okay, so if the next current node is null, that means you have reached the end of the linked list. So in our today's session, most of our examples, we'll be just having three nodes of us in our structure that will be traveling to 1, 2 and 3. That's it, small examples. Here I've shown you a syntax for initializing your node using structures. Okay, so struct node, int data, struct node, pointer variable, next. Now let us learn about traversing a linked list. So while traversing, it's basically a very easy job since you're traversing in a single direction. So displaying the contents of the linked list will be very, very easy. So we keep moving the temporary node to the next one to display its contents. So when the temporary variable is finally null, that means it is telling that we have reached the end of the linked list. So finally it comes out of the loop. So I've given a small syntax there. Struct node temporary variable pointer is equal to head, that is the starting variable. So printf, the list elements are while temporary is not equal to null, printf whatever your data you have entered, that will get printed, and you keep shifting. Temporary is equal to temp next. So this while loop keeps running till the node reaches the last node, that is null. Now let's learn about inserting elements to a linked list. You can add elements to either the beginning, the middle or in the end of the linked list, as I mentioned in the beginning. So now first let's learn about inserting in the beginning. So while you have to insert, first you have to allocate a memory for the new node. Then you have to store the data in it and then change the next of the new node point to the head. Then change head to point to the recently created node. So basically you'll be changing, as soon as you take the input of the new node, you'll be changing it as the first variable, that is the head. Head will get updated, telling that the new variable is the head first. So I've given a small syntax, you can check out. So struct node, pointer variable, the new node you're accepting. Malloc, you're using malloc function here that basically allocates the memory, a single large memory. Then you're assigning the new data, and the new data is being assigned to the head node, that is the starting node. Now let's learn about insert at the end. Here also we will be doing the same thing. You'll be allocating the memory for the new node, and then you'll be storing the data or accepting the value. So here we'll be traversing to the last node. You'll be changing the last node to the recently created node. So basically your null variable will be the last node that you'll be creating. So again, I've given a small syntax. You can just go through it. Now let's learn about insert at the middle. So here also you'll be allocating the memory and storing the data for the new node. You'll be traversing the node just before the requirement position of the new node, and you'll change the next pointers to include the new node in between. I've given a small code, you can check out. After this, now let's move on to delete from a linked list. So you can delete the same either from beginning, from end, or from a particular position. So how do you delete from the beginning? Point the head to the second node. So once you point the head to the second node, automatically it has to delete the first part. So the first part will not be displayed in the content. So head is equal to head next. So you'll be updating the pointer variable to the next node so that you can delete the first node. Now let's move to our next topic, that is delete from the end. How do you delete from the end? First, you have to traverse to the second last element, change its next pointer to the null. So here what you're doing is, the last element is the null character, whatever you're storing. So you have to travel to the last second element so that you have to change the next pointer to the null. That's how you'll be deleting it from the end. So I've given a small code again here, you can check out. The next, let's move on to the next, that is the delete from the middle option. So now, traverse to the element before the element to be deleted, change the next pointer to exclude the node from the change. So now you have to, if you have to delete the element that is 3, you have to go to the element number 2, change the pointer, and then you have to delete it from the chain. Okay, so here I've again showed your code. So using the for loop, you can change the temporary variable and then you can delete it. Now let us study about search an element on a linked list. So you can search an element on the linked list using a loop using the following steps. So we are finding an item on a linked list. So make head as the current node, run a loop until the current node is equal to null because the last element points to null. So in each iteration, check if the key node is equal to the item you have entered. So if the key matches the item, return it as true, otherwise return it as false. Next, you have something called as sort elements of the linked list. So how do you sort elements? Using bubble sort. So bubble sort is a very common method used to sort. So here a bubble sort is used in sorting ascending order. So here we have the following steps to sort it out. So make head as the current node and create another node for index. Okay, so if the head is null, then return it. Else run a loop till the last node till it's equal to null. So in each iteration, follow. That is storing the next node of the current in index and checking the data of the current node whether it is greater than the next node. So if it is greater, you will swap the current node and the index node, and then finally you can print it in ascending order. Now let us study something about sparse matrices. Now what is sparse matrices? A matrix is a two-dimensional data object basically made up of m rows and n columns. So therefore, having the total m into n values if almost of the elements of the matrix have 0 value, then it is called the sparse matrix. So in m and n columns, rows and columns, if you are having maximum zero digits in it, then it is called as sparse matrices. So why do you use sparse matrix instead of a simple matrix? Storage. So there are lesser non-zero elements than zeros, and thus lesser memory can be used to store only those elements. Second, Computing time. So time can be saved by logically designing a data structure so that it can traverse only in non-zero elements. So time saving also. So now let's see an example. So in this example, you can see 5 rows and 5 columns, 5 into 5 matrix. So here you can see more non-zero elements than zero elements. Now, how do you represent these sparse matrices? So representing a sparse matrix by a 2D array leads to wastage of lots of memory, as zeros in the matrix are of no use in most of the cases. So instead of storing the zeros with the non-zero elements, we only store the non-zero elements. This means that storing non-zero elements with triples, that is a row, column and a value. So here, as you know, why do we use sparse matrices is because it is first and foremost, it is useful for storage and computing time. So here there are lots of non-zero elements which can be removed, so that will free up your storage and it can save your time. So that is why you will be using a 2D array here to represent the matrix. Okay, so sparse matrix representation can be done in many ways. The following are two common representation. One is your array representation and one is your linked list representation. So in your array representation, how do you represent the sparse matrix? Now let's look into it. So 2D array is used to represent a sparse matrix in which there are 3 rows named as row, column and a value. Okay, so now rows and columns. So in which row and in which column which non-zero element is present. That's how you'll be representing it in array. So now what is row? Index of a row where a non-zero element is located, as I mentioned. Column, index of a column where a non-zero element is located. Now value of the non-zero element located at the index. Now let's get into an example. So here we are having a 5 into 5 matrix. So here our columns and rows starts from the index 0. Okay, so 0th row, 0th column. That's how we are going to start. So in the 0th row and your second column, we are having the digit 3. And then in your 0th row and in your 4th column, you are having the digit 4. And now let's move on the first row and your second column, you're having the digit 5. Then your first row and the third column, you're having the digit 7. Now in your second row, basically all your digits are 0. So you don't have to consider that row. Now let's move on to the third row. In the third row and your first column, you're having the digit 2. And your third row and your second column, you're having the digit 6. So this is how you'll be representing a sparse matrix using an array. So you'll be having a three memories, one for row, one for column and one for value. So so that we consider all the non-zero elements, and to consume your time and your memory, you're using this method. And there is also another method, that is using your linked list. So in the linked list, each node will be having your 4 fields. Okay, so these 4 fields are defined as, just like your array representation, you'll be having your row, you'll be having your column and you'll be having your value. But one extra thing here is the next node. So now what is this next node? This next node is something that stores the address. Now the next node is basically, like as you can see in the example, start, near the start, 0, your 0th row, second column, you're having your digit 3. And the last thing, which is empty, that box will be storing the address of your next node. So that is why you're having something called a next node. So your row representation, what is your row representation? To index of a row, column, index of a column of the non-zero element, value, the non-zero element, whichever is there in that index of the row and column, that element will be represented. So here the node structure, you can see the first thing, you have the row, then you have the column, and then you have the value and the address of the next node. So now let's move on to the next topic. Now, what is a double linked list? A double linked list can also be called as a doubly linked list, the DLL. So this is a special type of linked list in which each node contains a pointer to the previous node and to the next node of the linked list. So in a single linked list, we saw that the last memory, whatever we are having, contains the address of the next node. But here it contains the address of the previous node and the next node. So this can traverse both forward and backwards, as you can see in the diagram. So your head can have basically the null and also the head. Your last column can have your next as well as the null. Now you can see how the representation of a double linked list node is. So node of a doubly linked list, you will be using structures to represent this. So struct node in data, the pointer to the next node and the pointer to the previous node. This is how you'll be basically first defining it. Now, what is the use or what is the advantage of double linked list over the single linked list? As I told you in the beginning of the video, a double linked list can be traversed in both forward and backward directions. So the delete operation in DLL is more efficient if a pointer to the node to be deleted is given. Now the delete operation is more efficient. How? If a pointer to the node to be deleted is given. So here, because you're traversing forward and backward, so it is very easy to delete because you'll be having the pointer, directly the pointer, instead of how we did it in the single linked list. You're supposed to have something called the next node or the previous node, something you're supposed to have, so that you have to delete the node. But here it is nothing like that. Directly you get the pointer, you can easily delete it. We can quickly insert a new node before a given node. Since it is traversing forward and backward, you can insert it very easily. Instead of having something called the next node, something called the previous node, you can directly insert it. So in a single linked list, to delete a node, a pointer to the previous node is needed, as I mentioned just now. So to get this previous node, sometimes the list is traversed. Again and again it has to get traversed. So in double linked list, we can get the previous node using the previous pointer. You have a storage option for a previous pointer and the next pointer. So instead of traversing it once again, in double linked list, you can directly easily get the location of to insert the node or to delete the node. Now, what are the disadvantages of a double linked list over the single linked list? How is single linked list much more efficient than the double linked list? So every node of a double linked list requires an extra space for the previous pointer and for the next pointer. So it is possible to implement double linked list with a single pointer. So sometimes, it is very difficult, sometimes to store your previous node and to the next node. It is very complex, not an easy code you can handle. Okay, so all the operations require an extra pointer, that is the previous pointer or the next pointer, to be maintained. So for example, let's see an example. For example, in the insertion, we need to modify the previous pointers together with the next pointers. So if you have to insert, okay, so your previous pointer also should be shifted and even your next pointer also should be shifted. Even if you have to delete something, your positions will be shifted. So in the following function for insertions at the different position, we need 1 or 2 extra steps to set up the previous pointer. So it is very complex code, as I mentioned. So thank you guys. Please like, share and